Polynomial functions are functions that have any power of x, as long as that power of x is not a fraction. Okay, that's something you have to look out for. If x is a power of a fraction, then it's not a polynomial anymore. Okay, if it has an x in the denominator or a variable in the denominator, it's not a polynomial anymore, right? So as long as there are not variables in the denominator or any fraction exponents, then it is a polynomial, right? So that's what you want to look for when you're looking to see if it's a polynomial. Today we're going to talk about the end behavior of polynomials. So how do they end? As we go this way to the left, does the function end going up or going down? As we go this way to the right, does the function end going up or going down, right? And there's only two things you need to know about a whole long polynomial. It could be 18 terms long. And the only two things you need to know about that polynomial are the degree and the leading coefficient. If you can find the degree and the leading coefficient, you know how it ends, okay? So as a review, the degree is the largest power of x that appears. Standard form is when the terms are written in descending order, so highest power first and then lowest. And then the leading coefficient is the coefficient or the number of the term with the highest exponent. Okay? And then we will describe the end behavior of this polynomial based off of those two things. So first, let's talk about these types of polynomials here. These have some names. So this guy here is a linear polynomial. It's technically a polynomial. It doesn't have any x's in it. But it is because technically there's a little invisible x. It has an x to a certain power. And you want to have an idea of what invisible power there is? 0. Because that will then be 1, right? So that's a linear polynomial because it's just a, or no, I'm sorry, that's wrong. That's a constant. I'm getting ahead of myself. That's a constant because it's just a constant number. This one is your linear. This one's a line. Yours says -1 in front. I don't know why mine says 2/3. Not really sure where that came from. Yours has a little negative in front of your x, I think, right? Because that's a line when there's just an x. Anyone remember what we call it when it's x squared is the highest power? We had a whole unit on those kind. We have special formula for them. Yeah, it's a quadratic. This one's a cubic because 3 is the highest power. And then from here on out, a lot of times we just say 4th power, 5th power, 6th power, 7th power. But you might see some people call this guy fancy a quartic polynomial. And there's probably names as well for higher powers than that, with some fancy Latin names for numbers. But those are the ones we use most commonly: linear, quadratic, constant, and cubic. Let's start with the quadratic in the middle. The degree is the highest power. What's the highest power of the quadratic in the middle? The second power, 2, right? We see it right here. That's the highest power, so the degree is 2, because the highest power is 2. And that's the only term you need to pay attention to for this unit, is just the one with the highest power. The leading coefficient is the number in front of that term, or the coefficient in front of that term. So what's the leading coefficient here? What number is in front of this highest power? 4, right? So the leading coefficient is 4. So now I want you to fill in the rest. Write down the degree, the highest power for each of these polynomials, and the leading coefficient, the coefficient in front of that highest power. Are there no more of it? don't you write down for the rest with your table? All right, let's start at the bottom with the quartic. The very bottom. What's the highest power of the one on the bottom? 4. The highest power is 4, so we only care about this term right here. That means the degree is 4, so it's not always the first one, right? It will be the first one if it's in standard form, right? If it's written in decreasing order. But if it's not in standard form, then it's just the highest power. So the degree is 4. What's the leading coefficient? What's the number in front of that term? A -1. So the x is the part where you want to look for the degree, but when you're looking for the coefficient, you're looking at just the number in the front. So here, there's a little invisible -1 there. So the leading coefficient is -1. For the cubic, what is the degree? What's the highest power here for the next one up? 3. We're looking at this term. What's the leading coefficient here? There's a little invisible 1 in front. What's the highest power of this linear one? What's the highest power of x? What's the power of this x? 1. There's a little invisible 1 there, so what's the highest power? 1. So the degree of that one is 1. So then that means your leading coefficient is -1 because you're looking at that guy right there, right? And then this one's kind of weird, the constant. What's the degree of that one? That's 0, because the highest power of x is x to the 0, right? That's the highest power. And so the leading coefficient then is that little 3 that's in front of it. So the reason why we care about the leading coefficient and the degrees, it doesn't matter how many terms. Like this very last one has 5 terms. 1, 2, 3, 4, 5, right? If there was 20 terms, all you care about is the highest power term. That's it. You want the degree and the leading coefficient. If you know those 2 things, you know how the function ends. When the function ends, it will go one of 4 ways. It will end with both ends going up, both ends going down. They'll go in opposite ways this way or opposite ways this way, right? And it all depends on the degree and the leading coefficient. This guy here, when they go in opposite directions like this, opposite is always an odd degree. So if it has an odd degree, then it's going to go in opposite directions. So this one over here also will be when it has an odd degree. So when there are odd degrees, they're going to go in opposite directions. Now, how do you know if it starts down and goes up, or if it goes up first and then goes down? Well, that's going to be whether the leading coefficient is positive or negative. If the leading coefficient is positive, then it will start down and go up. I like to think about it as odd means opposite. They're going to go in opposite directions, and you'll also start opposite. So you'll start down because the leading coefficient is positive, so you would think you would start up, but it's opposite. So you're going to start down and then go up. And so when you start up and then go down, your leading coefficient will be negative. In order to get the end behavior to be both up or both down, right? When they're together, it's going to be an even degree. Even, you want to think about being the same. And since they're both up, we're talking a positive leading coefficient. And since they're both down here, we're talking a negative leading coefficient. So odd means opposite. Even means the same. So if it's positive, they're both going to go up. If it's negative, they're both going to go down. And so as long as you know that, then you know the end behavior. Any questions? Ringing a bell? Remember this vaguely from your past lives of Algebra 2? All right, so let's do some examples here. And I want you to specifically write down some information about each of these examples before trying to match them. Okay, so for each of these examples on the next page, I want you to write down the degree and the leading coefficient. So start by writing the degree and the leading coefficient down for each one. All right, so for this first one, the highest power is 4, so we care about that term. That means the degree is 4, leading coefficient is 3. For B, we're looking at the highest power being 3, so we're looking at this term. Degree is 3, leading coefficient -5. For C, highest power is 5, so that's the degree. Leading coefficient is a little invisible 1. For D, highest power is 6, so that's the degree. Leading coefficient is a little invisible -1. So now, this tells us everything we need to know about the end behavior. So what I want you to do when you're doing this is I want you to write down little arrows, what you know about the end behavior. So for number 1, for example, the degree is 4. Is that an odd or an even number? Even. And is our leading coefficient positive or negative? It's 3, so it's positive, right? So even and positive, even means the same, so they'll both be going up, right? So even, positive, both the same, so they'll both be going up. So next to it, I want you to draw these arrows, because you know that's what the end behavior looks like. For each of these problems, you probably don't need to draw the arrows, but I want you to do it for future problems. So for each one, I want you to do that. Now you can look at the graph and say which one has that kind of end behavior. Which one ends both going up? A, B, C, or D? Does this one end with them both going up? No, they both go down, right? Which one ends with them both going up? D does, right? So as we go to the left, this goes up. As we go to the right, this goes up. Okay, so this is D. And I want you to do the same thing with B, C, and D. Write down even, odd, positive, negative, and I want you to draw the arrows next to it. Then match it with the graph. So write down even, odd, positive, negative, and draw the arrows next to it. Then match it with the right graph. All right, so for B, the degree is odd, but my leading coefficient is negative. So when you have an odd and a negative leading coefficient, they're going to be in opposite directions, right? and I like to think odd opposite. So instead of starting down, I'm going to start up. So I start up and finish down. So odd opposite, leading coefficient negative, start up, go down. Okay, so which graph has this kind of end behavior? Which of that one starts up and ends down? Does this one? This one goes down first and then ends up, right? So it's not that one, it's B. This one starts down, or starts up, and then goes down. C has an odd degree as well, but now it has a positive leading coefficient. So it will start down and end up, because we're in opposite. So that is A. And then D has an even degree and a negative leading coefficient, so they're both going to go down. So even degrees are easy, and that will be C. So even together, both up or both down, whether positive or negative, odd opposites, and then you just have to say which way it starts. Does it start up or does it start down? And you can think opposite of the leading coefficient, because odd is always opposite. Any questions about this? This is the easy part. We're going to finish up with the hard part. Any questions? Okay. Now, most of the time, you're not going to just be matching it with the right graph. You're going to have to describe the end behavior. Okay? How do we describe the end behavior? Well, we have to say somehow, well, as the function goes this way, as the graph please go to the left, the function goes down. And as we go to the right, the function goes up. And that's the hardest part, is describing that end behavior. So we're going to do that for each graph here. So graph A, we already said has this kind of end behavior. So draw the arrows next to this. We're looking at graph A here, not question A, graph A. This one starts down and ends up, okay? So how do we describe that end behavior? Well, we're going to say, first, as x goes to the left, or as we go to negative infinity, as x goes to negative infinity, or as we go to the left, what does our function do here? Does it go up or down as we go to the left? What does this arrow tell us about our function? It goes down, right? So then you need to say that f goes down. This is describing the end behavior. So you're saying as x goes to negative infinity, so as we go to the left side of the graph, the function goes down, right? So this says as we go to the left side of the graph, the function goes down. And then we have to say what happens on the right side. As x goes to positive infinity, as the function goes to the right, or as we go to the right side of the graph, as x goes to positive infinity, what does my function do on the right side? It goes up, right? So now we need to say that the function goes up. So the part that you really only have to think about here is this part, right? You're always going to be describing what happens on the right and the left. You can do it in whatever order you want. You could do right first and then left, right? But one of these should always be positive and one of these should always be negative. So because you should always tell me what's happening at the right end and what's happening at the left end, right? This will change. Sometimes the function goes up on the right. Sometimes it goes down, right? So this is the only part that's going to change. So now let's do it for B. So graph B is this one. Let's draw the little arrows here. That on the left it goes up and on the right it goes down. Right? So the left is going up, the right is going down. If you want, you can just start by writing x going to the left, x going to the right, because that's always going to be the same. You're not having to think about that. We're just describing the right and the left hand side of the graph. Sorry, I think I said right first. Left and then right. So this says as x goes to negative infinity. So that's the left side, right? As x goes to negative infinity, what does your function do this time? It goes up. So now your function goes up. Positive infinity. As x goes to the right on graph B, goes to positive infinity, what does our function do now? It goes down, right? So it goes to negative infinity. Graph C was ending down on both, and graph D was ending up on both. Right? So C was going down on both, graph D was ending up on both. So now I want you to describe the end behavior for C and D. So do that part on your own. This, just like these, with this notation, describe the end behavior for C and D.
I just have a question on the first one, B and D.
Mm-hmm.
Why is it like flumped? I thought like since it's odd and then negative on B, why is one going one way and the other going the other way? Is it because
Every time it's odd, they're going to go in opposite directions.
okay, and every time it's like
Even, they're going to both go in the same direction. Right? So here we had even and negative, so they're both going down. Even and positive, they're both going up. Right? The odd ones are always going to go in opposite directions.
okay, thank you.
Yeah. So when you're describing the end behavior, you don't even have to think about this part. When you're writing down x going to negative infinity and x going to positive, one should be negative, one is being positive. This is just you saying, Mrs. Castillo, I'm going to tell you first what happens on the left side. Then I'm going to tell you what happens on the right side, right? Because this says as x goes to negative infinity, what's happening to the left, right? So for this guy, graph C, as we go to the left, as x goes to negative infinity, the function goes down, right? On the left, so then f of x is going to go down to negative infinity. But as we go to the right, f of x also goes down to negative infinity. This is the part that will be different for every problem, depending on what is happening to the function. Is it going down or up on the left side and the right side? So for D, you can do the left first and then the right. If you want to change your mind and describe the right first to the positive infinity and then the left, you can flip those. It doesn't really matter which one you do first. But as x goes to the left here, the function's going to go up. So f is going to go to positive infinity. And as x goes to positive infinity, so that's to the right, then f is also going up. So both are going up here. So both ends should be to positive infinity. This is the part that y'all are going to have the hardest time with, okay? But really the only part you have to think about is this part at the end, right? But you have to still have this in your answer because you have to tell me which one you're doing first, left or right. Any questions about this notation, the end behavior notation? All right, we're going to do one more together, and then you're going to practice the rest on your own. So let's look at number one. First, I want you to write down off to the side here the leading coefficient and the degree. What's the degree of this one? Number one. 3. Highest power is 3, so we're looking at that term. What's the leading coefficient for that term? 2. So is that an odd or even degree? Odd degree, right? 3 is an odd number. Leading coefficient is positive. So odd degree, positive leading coefficient. So now you're going to draw your little arrows. So since it's odd, you know they're going in opposite directions, right? It either is going to be this way or this way. Since it's positive, you want to think opposite. Start down and then go up. Okay? So start down and then go up. So then what you're really doing here is you're describing the end behavior. So what it says, determine if it's polynomial. If it is, using the leading term test to describe the end behavior, right? So to describe the end behavior, that's this right here. So this one here says as x goes to negative infinity, so that's to the left. So what does my function do as we go to the left? It goes down, right? That's what the little arrows tell us. So now we're going to say that. F goes down to negative infinity. As x goes to positive infinity, so that's to the right, my function goes up on the right-hand side. So now I got to say that. So you're describing how the function ends. So for each of these problems here, your answer should look like this. Okay, this is how your answer should look. All 4 pieces right here. This, totally up to you. I recommend writing it down just so you can keep track of it and you don't make mistakes. But this is just like your work for the problem, right? This is your answer. This is the description of the end behavior, okay? So for 1 through 6, that's what your answer should look like. But there's something that I just did automatically for question number 1. It says, first, decide if it's a polynomial. So before you do anything, you need to make sure it's a polynomial, because if it's not a polynomial, you can't describe the end behavior using the leading coefficient test, right? It's not going to work. So if it's not a polynomial, you should say not a polynomial. Is this one a polynomial? Did I assume correctly? Is this a polynomial? What bad things are you looking for if it's not going to be a polynomial? Yep, if the power is a fraction or if you have x's in the denominator, right? So if you have one of those 2 things, it's not a polynomial and you just stop. You can't describe the end behavior then. Okay? All right, I want you to finish the rest of these questions on your own. Yeah. So the odd is for the degree, not the leading coefficient. Yeah. So look at the degree. Is that an even or an odd number? So this, right? That's all you're looking at. So that's what's odd. Put an odd there. And then is your leading coefficient positive or negative? Does that make sense? Can I answer your question? If you have questions as you're working on them, feel free to ask. So even means they should both be going in the same direction. Are they both going in the same direction? And then negative means they're going down. There you go. So your answers for 1 through 6 should look like what's in that box. That should be your final answer. All right, I want you to take a look at the board because I want you to see a couple of important things. First, check problem number 2, okay? But put your pencils down. I want you to put your writing utensils down. I don't want you changing anything yet. Check problem number 2. Make sure your end behavior looks like this. Make sure you have the X parts and this part. If there's anything you need to change, you can go back and change it in a second, but keep your pencils down. Now I want you to check problem number 3. Keep your pencils down. Don't pick them up. How does problem number 3 look? If you think you might have gotten it wrong, take a closer look. I think you probably did it correct. Remember, this part here says we're talking about what happens as we go to the right? As x goes to positive infinity. Keep your pencils down. No erasing. Look at yours. Did you start with x going to negative or x going to positive? Which one did you start with? Negative? Is that okay? Can you start with x going to negative infinity? Yes. So when you're checking that first one, which one do you need to check it with? This part, right? So do you have x going to negative infinity and f going to positive infinity together? That's the important part, right? And then do you have x going to positive infinity and f going to negative infinity together, right? That's the important part. It does not matter which one you do first, right? You're just describing what goes right and what happens on the left, right? This is why it's important that you have this part in the first place, right? So that you're saying, Mrs. Castillo, I'm telling you what happens to the right first. The function goes down. Now I'm going to tell you what happens to the left. Now the function goes up, right? And you can do it in whatever order you want. But if it's Schoology, you're going to have to read what they wrote, right? And understand it, okay? So now you can get your pencils back out and check those. I do want to make a comment about number 3. What's the degree of number 3? What's the highest power in number 3? I'm pretty sure most people they were able to get this question right, but without understanding why. What's the degree for number 3? What's the highest power of this one? It's 4. How do I know the highest power of number 3 is 4? Why is the degree 4? Well, this one is not multiplied out for you. This is not in standard form, okay? This one you would have to, in order to figure out what the highest power is, you would have to multiply this out. But that's going to take a really long time to multiply it out, right? But you don't have to multiply it out. All you need to know what is the highest power. What will be the highest power of x we'll get from this guy? Right here. What will be the highest power of x we'll get from here if we were to multiply that out? Yeah, just this part right here. We'd have an x squared, right? That would be the highest power. If you did x plus 3 times x plus 3, you would get an x squared. What would be the highest power here? X squared. Multiply those together and you get x to the 4th, right? And then the leading coefficient will still be a -2. So this is what your first term will look like, okay? Because you'll take that -2 in the front and you'll multiply it out by x squared and x squared. You don't really care about what the rest of the terms are, right? All that matters is what that very first highest term is. So this will be your first term right here. Okay? And then that's how you know the end behavior. Okay? This is going to be really important for what we're doing in the next couple days. So I will leave this up for you to finish checking your answers. You may edit as you need to, but make sure that you had all the parts of the answers. And then we are finished for the day. If you want to grab the homework from up front, you can grab the homework.